Okay, so let us start the discussion by taking a very important example of a graph which is application in kinetic theory, not kinetic, thermodynamics. So thermodynamics, there is a very important graph of calculation of work done. So I am taking example, application of dy by dx. Okay, so it's a example from thermodynamics where we draw pressure volume graph. Pressure volume graph, it's an important graph because in thermodynamics we draw the pressure volume graph, that is also known as indicator diagram. And what does this graph gives? This graph gives the area under the graph. The area under the graph gives work done by the gas. Area under this graph gives work done. Right now we will not go into what is area, integration and all that, but right now note that area under this graph gives work done by the gas. Okay, and there are two important equations for which we calculate work done, and let us consider expansion process, and there are two expansion process we will take. One is called isothermal, and other we will take adiabatic. You may ask me, how did we jump to this topic? We have not jumped to this topic. I am explaining the application of dy by dx. And even if you are a grade 11 student, you will be able to understand this, because I am not going into the technical things of what is pressure, volume and all that. So basic thing, very basic thing we are discussing. Okay, so this is a graph, and any graph is relation, right? Last class I have discussed that graph means it's a relation, but it's an important kind of relation which is called function, special type of relation. Okay, so now this is a pressure and volume graph, and I want to plot the graph for these two processes, isothermal, adiabatic, and I will give you the formula for that or relationship between that. So isothermal process is P into V is constant. The relationship of pressure and volume is constant. Another is adiabatic process is P into V power gamma is constant. Here gamma is a factor or a number which is called ratio of Cp by Cv. So grade 11 students, you will understand it after, but you need to know that gamma is just a constant. Okay, and pressure and volumes are two variable which you are studying there, right? So pressure and volume are two important. Now I want to plot this graph, not just plot, I want to see the idea about slope. I want to study the slope. That means dy by dx I want to study. Here y-axis is pressure, x-axis is volume I want to study, and I want to understand that how the area under the graph is different during expansion and during contraction, because we will take contraction process also, but relationship remains same. Okay, let us try to understand this. So PV is constant. If I try to draw this graph, this is called a hyperbola, rectangular hyperbola. But let us take a particular pressure and particular volume. This is volume V1 and corresponding to this pressure is P1. So there will be a particular point on this graph, right? So this represent a pressure, volume represent some state of the gas. Okay, so this point represent a particular pressure volume that gives the state of the gas. Okay, now let us say that you are considering expansion. So expansion you are taking, so it will be like this way, expansion it will happen, and let us say now it has come here to a volume of V2, expansion happened, and this pressure is P2. So this is another point on the graph. This is representing another state, and the arrow here indicates, arrow here going from this state 1 to this state 2, right? This arrow indicates what? Indicates the direction of the process. Direction means it is going from state 1 to state 2. There is a change in the states of the gas. Okay. Now, what are we interested in? That we want to find slope. We want to find slope. So, what is the slope of this graph, and what is the slope of other graph? This graph also. So, this graph which I am representing, this graph is PV equal to constant. During expansion, we are representing that. Okay, PV is equal to constant. This is the graph. Okay, PV is equal to constant. That's the graph. Okay, so this graph PV equal to constant, that is representing what? That is representing here this graph which is isothermal process. Okay, now let us try to find out how it will look like. Let us try to do the slope. Slope we want to calculate, and then adiabatic also I will show what type of graph adiabatic will be. Let us first try to find the slope of this graph. PV is equal to constant. So I will differentiate small d we will take, and differentiation of constant. Differentiation of constant is anyway 0. Now d of PV. Now some of you may think, what is it? I am writing d of PV. I have learned dy by dx. Where is dy by dx? I am taking just d of this. If you have any confusion, you can take differentiation with volume. Okay, let us take differentiation of PV with volume. Similarly, here differentiation constant with volume. But anyway, we know this term will be 0 only. Right? Differentiation of constant is going to be 0. Now, how to do this differentiation? There are two functions. You have to take UV rule. So, leave P, differentiate volume with volume, and plus leave volume, differentiate pressure with volume, is going to be equal to 0. Okay, now you may say that what formula are we using here? How are we doing differentiation? Which formula it is? So don't worry, have patience. I will tell you what is the formula. Okay, this is a rule which I am using here. I am assuming that you have zero knowledge, and from zero knowledge I will give you, but you have to have some patience. Okay. So suppose, for example, if I have to differentiate two functions like y1 into y2 with respect to x, I am differentiating. So y1 and y2 both depends on x, both are functions of x. So in this way we use this formula: leave first function, differentiate second function, and leave second function and differentiate first function. This is the property. That property also today I will discuss. There are a lot of properties, but I have just taken the application, so something is coming in between that we will try to understand. So I have applied this property. So P I have kept outside and I have differentiated V with V. Then I have taken V outside and I have differentiated pressure with volume. Right? And all of us know that dV by dV is 1. So they may cancel out. So this is P into 1 plus here this is volume, and this is dP by dV. dP by dV is the slope of this graph. Let us try to understand. Dy by dx is slope, and this is pressure volume. So dP by dV is the slope. So calculate dP by dV. dP by dV you will calculate as minus P by V. This dP by dV is the slope of this graph. Slope of this graph. Okay, which graph? Pressure volume graph. For which process? Isothermal process. Now we will do same for adiabatic. Let us do for adiabatic also. Try to calculate adiabatic. Adiabatic process. For adiabatic you do. For adiabatic process you do. So adiabatic process PV per power gamma is constant. Same manner, let us do the differentiation. So differentiation of PV power gamma with respect to volume is differentiation of constant with respect to volume. We can differentiate both sides. So constant differentiation is 0. This again we are going to use this rule, and note that P we will take as one function, and V we will take as another function. V for power gamma we will take as another function. Okay. So let us do that. So when we are doing here this P and this is volume power gamma. Gamma is a number. So first we will take P outside and we will differentiate V power gamma with respect to volume. Then next we will take V power gamma outside and we will differentiate pressure with respect to volume. Now here another formula which you need to note here. If you do not know formula, note it. I will come back to this formula after. Differentiation of x power n with respect to x is n into x power n minus 1. This is a very important formula, and as you are starting the calculus and its basic application, you will definitely use this formula. Lot of questions you will use. So differentiation of x power n with respect to x is n into x power n minus 1. So we are going to use this formula here. So we are taking volume differentiation, right, with respect to this, but power gamma is there, so we'll use that formula here. Let us use that. So here this gamma will come out, then volume power gamma minus 1. That's the formula we have used. And this is volume power gamma, this dp by dv, which is the slope of this adiabatic graph. Let us try to calculate. Let us try to find out dp by dv. So dp by dv, if I calculate, I get minus here P into gamma volume power gamma minus 1 divided by volume power gamma. So what do we get? We get minus P into gamma, and in denominator we get V. So very important thing is that this slope dP by dV is coming as minus gamma times pressure by volume. Very important thing. Okay, this is for adiabatic process. Adiabatic process. And here we have got this for isothermal process. So this we need to note. For isothermal process, pressure volume graph, that slope is minus P by V. And for adiabatic process, the slope, that slope is minus gamma times pressure by volume. Why are we discussing all these things now itself? You may ask that. Now I will come to the point when we have to compare the slope. That is where many of the students face problem. After this, see, this chapter comes in grade 11 after completing almost 80 or 90% of the syllabus. There also students face problem. Why? Because the basic maths is not very clear. That is why you need to understand and focus on basic maths from the beginning itself. Okay. So now let us try to understand the graph, and this we will apply that. Okay. So I want to represent this pressure volume process PV graph indicator diagram. From this point to this point I want to draw, because I want to show expansion here, volume 1 to volume 2 expansion I want to show, right? How to show expansion here? So already I have told that this graph I am going to take as one of the graph, right? And another graph also I will indicate, and you tell me which graph will be isothermal adiabatic. Okay. Now you tell me which graph is isothermal, which graph is adiabatic. Note that we are starting from the same initial state. That means initial pressure, initial volume of the gas is same, but final pressure and final volume is same. Note that final volume is same for both the gas. Why? Because this vertical line is the same volume, but final pressures are not same, because these 2 points are not pointing to the same pressure. You can see here, right? Their pressures are different. So here we are doing expansion between the same volume to the same final volume, between same initial volume to same final volume. That is what we are doing. Pressure we don't have to worry. Okay, but initial condition of pressure is same for both the gases. Final pressure conditions are not same for both the gases. Okay. Now here can you tell which graph is isothermal, which graph is adiabatic? If you have marked up, then you may tell what is the science behind this. Which graph is upper, which graph is lower? That is what is given by the slope dp by dv. I will write again. For adiabatic, it is minus gamma times pressure by volume. For isothermal, For isothermal, it is minus pressure by volume. Yes. Can you tell me which graph is isothermal, which is adiabatic? Let's take this as the first one, and this below graph as the second one. Second graph. Okay. So second one is adiabatic. First one is isothermal. That is what you are saying. Huh? How to understand this? Very very important one. That is what we need to look for the slope. So now let us try to look for slope. Means we know there is a common point here. Let us draw tangent here. Let us draw tangent at this point, because this is a common point. We can draw tangent and compare. Let us draw tangent. So I will draw tangent. For the first graph, I am going to draw tangent line. This is the tangent line for first graph. Okay. And let us say it is making some angle theta 1 here. Then second also I will draw tangent. Second I am drawing tangent. This angle is theta 2. Now you tell me, from here you tell me which has more slope, which graph should have more slope. That you tell me. Which graph is more slope? Two slopes are there. Adiabatic aspect. Which has more slope? Again, if you have any doubt, let me repeat it. Previous class, no. Try to understand. I will again repeat. So, what is slope means? Slope meaning of slope. Suppose this is x and y graph. Okay, any graph is there. So, slope means what? Suppose if there is a point and I am taking tangent here. If I am taking tangent here at this point. So, this theta, this tan theta is called slope, which is nothing but dy by dx. Okay, now I will again repeat. If theta is large, if angle is large, slope is more. If angle is less, slope is less. That's a simple rule. Okay. If angle is more, slope is more. Angle is less, slope is less. Very simple funda. Okay. Now tell me here, which is more? This is minus gamma times p by v, and this is minus p by v. Both are negative numbers. Which is more? Which is more? Yes, minus V by V, because here gamma is not there, but here gamma, so extra negative it is coming. So negative it is going smaller. This is small, this is large, that you have to note. This is small and this is large. Okay, this is where confusion people have. This is large, this is so large means the isothermal must have larger slope, that's all. Isothermal must have larger slope means larger angle should be there. And adiabatic should have a smaller slope means a smaller angle. Now come back to this point and tell me whichever has larger angle. Which has large angle? Tell me. Theta 1 or theta 2, which is large? Come on, see, I think it's not very difficult. Diagram may be looking proper only. You decide. Theta 1, sure? Yes? See, here this angle is this is theta 2 and it is bending like this, theta 1. So theta 1 is large. Try to understand this. This is theta 2 and it has bent like this, theta 1. So theta 1 is larger angle. Correct? Yes, Sam, are you getting this? Try to understand this. See, suppose this is a line. Okay, I will show with hand. This is line. If this line is going like this way, the angle is more, right? This is the line which is making angle with x-axis. So if this line is bending like this, more angle. So here this line is theta 2 like this and it is bending like this. So angle is increasing here. Clear? So if you go from theta 2, this line to this line, theta 1 is larger, we can clearly see here. Theta 1 is larger than theta 2. So tan theta 1 is also larger than tan theta 2. And tan theta 1 is the slope. That slope is larger than this slope. So which slope is larger? Isothermal is larger than adiabatic. So definitely this one must be what? This first graph, this one, this means this first graph. First graph must have large slope. Large slope means first must be isothermal. Clear? Yes. First must be isothermal. So this slope is for this one now. This first must be isothermal. I will write it here. Okay, first graph must be isothermal here. Isothermal. And second must be adiabatic. Adiabatic. Because this second angle theta 2, this theta 2 is smaller. Theta 2 is smaller means that is adiabatic slope. Okay. Are you clear about this? Yes. So now if I say which area is more, so graph which is above, that area under this graph will be more. That means work done in isothermal will be more than work in adiabatic. But I am not going into the work concept, okay? Because just I am introducing this which slope is larger. So these two graphs are there, and which slope is larger you can now understand. Yes, all of you are clear about this. Now, suppose if I go for this was expansion, example of expansion. Now take for example of compression. Compression example I will take now. Okay. Let us go for compression example. Compression. Compression means we are going from higher volume to lower volume. So in this graph, pressure volume graph I will take from higher to lower. So this will be V1, V1 will be larger, V2 will be smaller, and take this point here and try to make here, take a vertical line here. Okay. Now from this we are going into two graphs. I will try to draw graphs properly. We don't know how this will look like, but I am taking one graph like this and I am taking another graph like this. Two graph I am taking. They are coming at two different points again. Pressure points may be different. We do not know the pressure points, but volume is same. That means between the same volume we are compressing. Between the same volume we are compressing. Again here the idea is that we want to find out which is more like slope. Which graph I want to identify which graph is isothermal, which graph is adiabatic. That is the main issue. How do we identify that? Again, I will draw the slope at this point. Okay, let us try to draw the slope. I will take this red color as the first graph. Red color I have chosen as the first one, and green color I have chosen as the second one. Okay, let us draw this graph. So first I am drawing here slope. This slope is going to be like this. This is the line slope for the first graph. At the same point, we will draw the slope to the second. So second should come like this is second. I hope this may be better. Okay. So this pink color line is slope of the first. This blue color line is slope of second. Then here let us also make the angles. Angle I want to represent for this one. This angle is theta 1 and this angle is theta 2. Okay. That angle is theta 2. So which is larger angle? Are you able to visualize it? Which angle is larger? Which line is more bent? How do you know that? This line, and this line is more bent. So theta 1 is more, right? Can you see that? This is theta 2 and theta 1 is more bent. So this theta 1 is going to be larger than theta 2. So tan theta 1 is going to be larger than tan theta 2. That means this must be the slope of isothermal. Isothermal. Because isothermal slope is greater than adiabatic. This is adiabatic. So this slope of the first one is drawn for this one. So now first one, isothermal has come below, adiabatic has come above. This is what is, and process is like this. Process arrow, you need to also show the arrow. Arrow can be shown like this. Okay. So now you see this below graph. This below graph is isothermal. This first one, first graph, that first is below graph is isothermal. Isothermal. And the above graph is adiabatic. Second number graph is adiabatic. This is a very important application of this law. So while you are considering expansion, isothermal is above and adiabatic is below. But while you are considering compression, uh, adiabatic is above, isothermal is below. That's why the calculation of work is different. Okay, work means area below the graph. So definitely here the area below the adiabatic is more than area below the isothermal. Clear? So in compression, adiabatic work is more than isothermal. But in expansion, isothermal work is more than adiabatic. I am not again going into the work done calculation, but this is the application of slope of the graph. Clear? All of you are clear about this? Yes. All of you have joined. Anyone else who has not joined or trying to join, you can update me. Okay, so let us move to the next. So dy by dx concept we have discussed last class. Last two classes we are discussing that concept only, dy by dx. Today we have seen the application of dy by dx. Double differentiation also concept we have seen. So single differentiation, double differentiation concept we have seen. Today we have seen one very important example. Then now we are going into the formulas of dy by dx and properties of dy by dx. Okay, let us go into that formulas of dy by dx. Formulas dy by dx. Okay, how the formula comes, that we don't have to look for that, because to derive the formula you need to learn little mass of limits, continuity, differentiability. You need to learn about that. So right now we are not going into that detail. Okay, how to, but if you want a simple example, that I will derive a simple example, then I will write down the formulas. Okay, so first simple example you take. Suppose for example y is equal to x square. Okay, y is equal to x square. Suppose you change x, y will also change, right? So x change to x plus delta x, y will also change to y plus delta y. This is equation number 1, this is equation number 2, and if I subtract y plus delta y minus y, this is x plus delta x whole square minus x square. So from here y got cancelled, you got delta y. You can open this a plus b whole square, a square delta x whole square plus 2x delta x minus x square. Here x square terms will go away. So delta y becomes delta x whole square plus 2x delta x. Now I will take delta x common, or I will divide by delta x. So delta y by delta x is equal to delta x plus 2x. First of all, we note that delta y by delta x in a graph represent what? That you remember, suppose this is x and y graph is there, right? Any type of graph is there. What is delta y by delta x represent? We are taking two different points, right? This is a secant line. Remember, this is a secant line. And if I take Delta x delta y means in this triangle this is delta x and this is delta y. So this theta or tan theta, which is the ratio of delta y by delta x, this tan theta is slope of secant line. Slope of secant line. But I want to find dy by dx. Note that I want to find dy by dx. So dy by dx means we want to take very small changes, not a delta change. Delta change is a big change. I want to take very small change. So I have to apply a condition here so as to make delta x almost 0. For that we apply the condition of limits. So now we apply the condition of limit both sides. So apply limit delta x tends to 0. That side also apply limit delta x tends to 0. So this delta y by delta x left hand side, right? And right hand side is this delta x plus 2x. So what is the meaning of limit delta x tends to 0? Limit delta x tends to 0 means these 2 points are going to be the same point. So this delta x delta y is almost going to be very small. So this ratio now we will write as dy by dx. dy by dx. And here we'll try to substitute delta x tends to 0. So this first term becomes 0, second term is 2x. So that's how we are getting an important result. Dy by dx becomes 2x. When if y is equal to x square. So if y is equal to x square, dy by dx becomes 2x. Now this is the approach of deriving for different functions. You can derive dy by dx, but the only thing is that you need the knowledge of limits. If you do not have the knowledge of limits, you cannot go beyond that step. That's what it is. So for that you need to learn limits in math, then only you can derive formula for differentiation. But I am not going to do that because that's a math topic. What we need to do is here to learn the important formulas. So now we are going to write all the important formulas for differentiation. Okay, so let us write starting from the formula number 1. Start from formula number 1. So differentiation of x power n with respect to x is equal to n times x power n minus 1. This is formula number 1. Note that here this x power n is y here. Okay, we are choosing here y as x power n and we are calculating dy by dx. So y is x power n. Here n can be any number. So that number will come outside and power will decrease. So note that in differentiation power decreases and n can be any power, whether positive, negative, it doesn't matter. Okay, that is the first formula. Then let us go next. So in this case also note that dx by dx can be written as 1. Dx by dx can be written as 1 because you put n as 1 here, you will see 1 into x power 1 minus 1, that means x power 0 is 1 and 1 into 1 is 1. So dx by dx is 1. You may say that I am cancelling out. Don't do that mistake. Cancelling out you can do, but that is not a proper way of learning. Here we are applying a mathematical operation. This is the mathematical operation. Okay, let us move to the next formula. So now also note that differentiation of, now let us say trigonometric function. So trigonometric function means y can be sin x, y can be cos x, y can be tan x, y can be cot x, y can be secant x, y can be cosecant x, y can be all these things. So let us write the formulas for that. Very important formula. Differentiation of sin x with respect to x, that becomes cos x. Next, so second I will write all trigonometric formulas. Differentiation of cos x with respect to x becomes minus sin x. Next, differentiation of tan x with respect to x is secant square x. Okay, then differentiation of take the reciprocal, cosecant x with respect to x is what? What is cosecant x differentiation? Tell me. minus cosecant x cot x. Similarly, differentiation of secant x with respect to x is secant x tan x. Next, differentiation of cot x with respect to x is minus cosecant square x. Okay, so these are the 6 formulas we must remember. Sin x differentiation with respect to x is cos x. Cos x differentiation with respect, note that this x here and this x must be same. If they are not same, you cannot apply this formula. Okay, so sin x differentiation with x is cos x. Cos x differentiation with x is minus sin x. Tan x differentiation with x is secant square x. Cosecant x with x differentiation is minus cosecant x cot x. And secant x differentiation with x is secant x tan x. Cot x differentiation is minus cosecant square x. These 6 formulas you have to remember. Now tell me, you must have remembered these formulas. Tell me, all these formulas are correct, because sometime I may make mistake also. Tell me, all these formulas are correct or not? I may also forget because mostly we are not using these formula. Maybe sine, cos, tan we use most of the questions in physics. Generally, these formulas secant x, cot x, cosecant they don't come. So tell me, is this correct differentiation formulas? You also not remember. You have to remember more than me because you have to use problems. Correct. Sin x differentiation cos x minus sin x, tan x is secant square x, cosecant x is minus cosecant cot, secant x is secant tan, cot is minus cosecant. I think it is correct. Okay, so all these formulas you have to remember. This is what is trigonometric function over. Then next, let us go for the next log function. We can go log function. Next page. Let us take next. Log. Differentiation of log. Log I am taking first log base c, which is written as ln. I will also explain what is ln x means. Okay. So differentiation of ln x is 1 by x. Note that. Okay. Definitely x cannot be 0. So let's try to understand what is ln x, or what is the meaning of log first of all. Let us see that log. So log base uh, x, or let's try to understand first like this way: 2 power 3, 2 power 3 z, right? 2 power 3 z. So log is a mathematical tool to express the power. Okay, how to express that power? So we write this base 2 comes in the base of log, and this 8 comes here, that becomes 3. So this power 3 can be written as log same base and 8. That is what is a method of writing log. Okay, right? And there are a lot of calculation mathematical properties of log that you will be learning in maths. So right now I am not going. So but log and exponents, they are like brother and sister, they are related together. So an exponential thing can be converted into log. Log can also be converted into exponents, right? And what is ln x means? Ln x means log base ex. Now you may ask, what is this e? So note here that e is an irrational number. E is an irrational number, and the value of E is nearly 2.718 dot 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 dot. It goes on. Okay, because it's an irrational number, it will never stop. It will continue after decimal. It will never end. Neither it will repeat. Right. So now repeating, not means ending, like that. Right. And some values of log you should remember, like for example, ln2. ln2 value is 0.693. This is one of the most famous calculation that is used in that. But I will also give you the value of ln3, ln5, because in some questions, if it is a very tough paper, some questions, if they have not given you in the exam hall, then what will you do? Okay, there is no option before you then. So let's take this ln. Okay, ln values I will tell. ln3 also remember. ln3. ln3 is 1.098. 1.0 up to 3 digit I am giving. 1.098. Remember this. And ln5 also remember. ln5 also remember. ln5 is 1.609. Up to 3 digit I am giving you the values. So better you mug up, better you remember. Why basically we know ln2? Because ln2 is used in radioactivity, in chemical reactions, chemical kinematics 0.693, many places we use it, right? But ln3 and ln5 we don't use. Unfortunately, if they give in the question and if you don't know the value, then you are in trouble. So better remember it. Okay? At least during approximation, it will be helpful. Okay. Okay, so this you need to note that ln x differentiation formula is this. And what about if base is something else? Then how to do that? So in here itself, I will give that. If suppose some other base is there, let us say base is some other a, let us say differentiation of this with respect to x. So what will happen in this? What is going to happen in this? What do you think? What will happen? Hmm? In this, how do we approach differentiation? We have to change the base to e. So you can write ln x by uh, base change rule you can apply. Okay, like you keep ln x ln a, right? Like for example, a log ax can be written as log base ex by log base ea. So ln a factor will come in denominator. So this formula will come as 1 by ln a, and then ln x differentiation becomes 1 by x. So you need to remember this formula. Okay. You need to remember this formula. Log base ax differentiation becomes 1 by ln a into x. In x both are in denominators. Okay. So this factor and the 1 by x factor comes out. Yes. Okay. Then let us move to next. Next. Differentiation of exponent also, let us say. A per power x. A power x differentiation. What is differentiation of a power x? A power x differentiation. Or if you want, you can take first e. A per power x you take, no problem. A power x differentiation you take with respect to x is a power x ln a. Correct? Like this. That's formula. And suppose a become e. So that special differentiation also known. Differentiation of e power x with respect to x becomes e power x only, because ln of e, because you are substituting a as e, ln of e is going to be 1. Note that. Why ln of e is becoming? Because e power 1 is equal to e. So if I apply log concept here, so log base e is equal to 1. That is what is called ln e, right? This is what called ln e. So ln of e is 1. Okay. Not only ln of e, ln of a with a, ln of j with j, whatever it is, but these two things are same, so that it will become 1. Okay. So this formula also we must remember that. Okay. So we have done. Then what else is remaining? Hmm? Most of the formulas are over or not? Over. Correct? Huh? So we have seen a basic polynomial function, then trigonometric function, then log function. Then exponent function. There are inverse trigonometric function also. I am not going into that. Inverse trigonometric functions are also there, but if I go, then it will purely math class. So previously, when I had recorded the class, when I just started teaching on online, that time, that short term course which I started, there I have given a detailed description of inverse trigonometric, hyperbolic functions and all that. So those who want very strong foundation in basic maths, you can go through those videos. There are lot of formulas collected from different books, and I have given that. Okay, if you want, you can go through that. But right now, these formulas are sufficient to solve questions. Okay, let us move to the next properties of differentiation. Properties of dy by dx. Properties of dy by dx. So first property, that differentiation of a constant is going to be, differentiation of constant with x is going to be 0. Second, because constant does not change. Next, differentiation of a constant multiplied with a function. Differentiation of a constant multiplied with a function y, let us say, with respect to x, that constant will come outside this. Constant will come outside this dy by dx. Next, third, differentiation of um, differentiation of let us take product rule. We can take product rule. Product rule means product of two functions. First you take sum rule, sum or difference rule. So sum of two functions, differentiation with respect to x, or it can be difference of two functions. So what happens? This dy 1 with x plus minus comes according to that, dy2 with x. Very simple. If plus sign is there, plus will come, minus sign is there, minus will come. So differentiation can be broken into two parts like this. Okay. Next comes the product rule. This is the product rule which we have shown applications. So differentiation of the product of two functions with respect to x is going to be equal to leave first function, differentiate second function with respect to x, plus leave second function and differentiate first function with respect to x. That's the product rule. Then next is the quotient rule. So differentiation of division of two functions y1 by y2 with respect to x. So in this, what we need to do is try to remember this formula. First you make numerator denominator. In denominator put the square of the second function. Second function square you put, and then leave the second function and differentiate first function with respect to x, minus leave the first function and then differentiate the second function with respect to x. Okay, so that's how we will do, and it has got a major application in many questions. Many questions it has got major applications. One of the major application is that when this differentiation y1 by y2, when this differentiation is 0. So one shortcut, you think like that, whenever this y1 by y2 differentiation is 0, directly put numerator 0, because this will get multiply with 0, that will become 0. So numerator 0 means y2 into dy1 by dx is equal to y1 into dy2 by dx. That's a very important idea. I will give one idea. This application comes in electric field. Okay, electric field. You know, the suppose if you take a charge ring, let us take a charge metal ring. Okay, this is the application I am coming here in this topic. So there is some charge here, let us say, and this is a ring of radius r, capital R. And on the axis of the ring, there is a point P. Okay, there is a point P which is at a distance of x from the center. Okay, center of the ring. Now the formula for electric field is kqx by x square plus r square power 3 by 2. So E is nothing but electric field. Now question comes that what is the maximum value of electric field? That question comes, okay, or where is the value of x where electric field become maximum. So when this concept come maxima minima concept, so that means the differentiation of electric field has to be 0. Differentiation with respect to x is 0 for maxima or minima. For electric field becoming maximum, here we will apply differentiation 0. Now here note that kq is anyway constant. Kq is constant. So basically you need to think of the differentiation of this x by x square plus r square power 3 by 2. This differentiation with x has to be 0. Now you can see this is a quotient rule. It's a division of two functions. Right, you are seeing the upper function y1, lower function y2. Upper function y1 is x, lower function y2 is this x square plus r square power 3 by 2. Now without going into more steps, you can just apply this idea that if this is 0 means, 0 means what? If that is 0, suppose if this term is 0, then y2 into dy1 by dx is equal to y1 into dy2 by dx. Direct apply that. Okay, you can save a lot of steps. If I do that, that means I will leave first, anyone you leave, it doesn't matter. Suppose if I leave first this y1, y2 is there, no? I leave y2 first. So x square plus r square 3 by 2 I leave. And then I differentiate the numerator x with respect to x, and this has to be equal to, if I leave x and I have to differentiate this x square plus r square power 3 by 2 with respect to x, like this. This step will reduce almost all the calculation. The dx by dx is 1, so this become x square plus r square power 3 by 2 is equal to, x comes out, and here you apply chain rule. You have to apply chain rule, I think we will come there. But when you apply differentiation of this directly, you cannot do. So chain rule I will apply here one step to show how are we applying. So I will write this power 3 by 2 with respect to this, and then this with respect to x, like this. This means what? This means it is the same x square plus r square, x square plus r square, x square plus r square. Okay, this is what we are doing. So now if you open up this step this side, so this formula now you apply. It is like x, okay, x power n with respect to x. Now you can apply. So 3 by 2 into this whole power what? 3 by 2 minus 1 it will be, correct? This whole power 3 by 2 minus 1, 3 by 2 minus 1. And here you can break into two components. So first you need to do differentiation of x square with x and differentiation of this r square with x. Okay, here I am writing more step to make you things clear. So here x into 3 by 2, and then it will become x square plus r square power 3 by 2 minus 1 means it is half, right? And here x square differentiation become 2x, and this differentiation becomes 0 because r is constant. So what do you get? And note that this side is x square plus r square power 3 by 2. So bring x square plus r square one side, bring x square plus r square terms one side. So this is 3 by 2, and that half will come, and divided means minus half will come, and this become 3 by 2 x, and here becomes 2x. Now you see 2 got cancelled, so you got this as 3x square. And this side 3 by 2 minus half is what? 3 by 2 minus half is what? 1 only. So x square plus r square power 1 means that only. And that side come 3x square. So this is a very important result, that 3x square minus x square, 2x square become r square. So x becomes plus minus r by root 2. It's a very important result in electric field. Where is electric field maximum? This place electric field is maximum. That means if this is the ring of radius r, electric field is maximum at a distance of r by root 2, either this side or this side. From center, either this side or this side. From center, either this side or this side. Plus or minus means left side, right side. Electric field is maximum there. Okay, that we should know. And what is maximum electric field? That we substitute. If you want, you also calculate by substituting the maximum value of electric field. So electric field maximum now you calculate if you want. Maximum electric field. So KQ x, kqx, x is r by root 2, right? Kqx, r by root 2, then what? R cube, right? Correct? Kqx, no, not r cube. R square plus x square. X square means r square by 2 power 3 by 2. Correct? Solve it. Now you can solve how much it will come. So kq r by root 2 will come, and here it will become what? 3 r square. So 3 r square, 3 as r square by 2 power 3 by 2. So what will happen here? Kq, this r cube r square factor will come, kq r square factor will come. Okay, and after that what will happen? Take out this. So this is 3 power, uh, that means 2 will come in the numerator. 2 power 3 by 2 means 2 root 2. Root 2 root 2 will get cancel, a factor of 2 will come here. Okay, and here 3 power, that means 3 root 3 you can write. So this is the value of maximum field. This is the value of maximum field. And of course, as a new student or JEE student, you need to remember this value. Suppose by chance direct question come, sometimes some direct question come. Although you may say it's a formula based question, but how many students remember this formula? Hardly few students will remember that formula. So now you remember it like this. So you know the formula for point charge electric field kq by r square. You multiply this with a factor of 2 by 3 root 3. This factor you remember, 2 by 3 root 3 multiply, that's the maximum field. Okay, maximum field, this is the formula for maximum field. And at what distance maximum field happen? R by root 2. Okay, R by root 2, either this side or that side. Of course, this side field will be this way and this side field will be that way. So you may say this is like minimum. Minimum means it is because of minus sign, minimum is there. But the value is maximum only. Magnitude is maximum. Correct. So this is one of the major applications that comes in many calculations in physics, mostly starting with grade 11 and grade 12 in gravitation, and many other chapters it will come. Even in magnetism it comes. Right, calculation of potential, potential energy, all this calculation it comes. Okay. So that's what it is. Example, we are discussing about what? We are discussing about this formula number 5. Then, then what? Formula number 6 we will go. That's the most important formula, which is the chain rule. Chain rule is the most important formula. Chain rule. Chain rule. What is chain rule? Now try to understand what is chain rule. Suppose, for example, if we have to differentiate 2x power 10, 2x power 10 power 100 with respect to x. Chain rule is a rule which you can understand, then life will become easier, because many questions can be solved and almost everything will come under chain rule, all calculation of differentiation. So those who are in grade 11, those who are beginning, they must master this chain rule. If you master this chain rule, then all kind of questions can be solved. Okay, most of the questions will involve chain rule. Then how to, so here you note that this power, this is not x. If this is x power 100 with x, then you can apply the formula. But this is not x, this is 2x plus 10, it is something else. So what you need to do is, you need to make sure that this term and this term must be same. Right now they are not same, but we can make them same. By little bit smart method, we can make them same. How can we become smart here? We can do this 100 and then we will make the same term here, and then again we will repeat the same term here, and we will keep the x term in denominator. So we have repeated here this term. Repetition of this term doesn't make any difference because this term anyway get cancelled out. Okay. That is why we can do that. And when we can do that, now we can apply formula. This power 100, we can apply formula, because now you can see that these terms are same. So it is like differentiation x power n with respect to x. Now we can apply. Okay, so let us apply that. So 100 will come out. and 2x plus 10 power 100 minus 1 we can apply. This differentiation we can break because there are two terms are there. So differentiation of 2x we can do first with respect to x, and then differentiation of this constant 10 with respect to x we can do that. Right. So how much it becomes? It becomes 100 into 2x plus 10 power 99. And also solve this bracket. So here 2 comes out. This is dx by dx. And note that constant differentiation is 0. So that gives us what? That gives us 100 into 2x plus 10 power 99. And here dx by dx is 1. So this gives us 2. So finally the answer is 200 into 2x plus 10 power 99. That is the differentiation of this. Are you clear about this? Yes. All of you have got this? Okay. So now today we have covered the differentiation formula and some examples and properties of differentiation. So now you can solve problems. Problems. How will you solve problems? Problems I have already uploaded as a test. Okay. So what you need to do is you need to work out the problems there. Already test is there. I will send the links. So now start working on the test paper. You have to sit down and write the test. On the link you open, write the test. If you have not installed the app, you install the app and write the test. Even without installing the app, you can write the test, but it will be better if you install the app, because many communications which I am doing, you will get updated there. Okay. Fine. So let us find this. Then next class we'll go further into integration and other things. Right? Okay. Then we'll meet in the next class. All